A telescope can detect objects within billions of light years, but what it observes is not only remoteness in space, it is also remote in time. When astronomers look at the primitive universe, they are not seeing what the cosmos is like today, but what it was like when it was barely half its current age. If you like this kind of content, don't forget to subscribe and give like. Your support helps us keep sharing fascinating discoveries about the universe. Let's explore how a recent find has changed our understanding of black holes. An international team of astronomers has analyzed the brightness of the most distant quasars of the universe. This discovery questions a key assumption in astrophysics, that the structure surrounding supermassive black holes has remained unchanged throughout the history of the universe. For decades, scientists have studied the relationship between ultraviolet light and X-rays emitted by quasars. This link, which seemed universal, was fundamental to understanding supermassive black holes and their environment. But what if this relationship is not as constant as thought? The new study shows that the correlation between ultraviolet light and X-rays has not been the same throughout cosmic history. Researchers compared nearby and distant quasars and found a significant deviation in this correlation, suggesting that the physical conditions around black holes have evolved. This change implies that the crown, which transforms ultraviolet light into X-rays, may not always have the same shape, density, or temperature. What was previously assumed as an immutable feature of the universe has proved to be variable, which has profound implications for astrophysics. To reach these conclusions, the team used observations from the Rosetta telescope and XMM-Newton observatory data. This combination allowed to analyze an unprecedented sample of quasars, revealing trends that had not previously been detected. One of the most innovative aspects of the work was the use of a robust Bayesian statistical model. This strategy increased the accuracy of the results and confirmed that the rupture in the correlation between X-rays and ultraviolet light is real and consistent. The immediate consequence is that the ultraviolet ray-X ratio can no longer be considered a universal constant. This means that cosmological models based on it should be carefully reviewed, opening up new questions about the evolution of quasars. The study concludes that the physical processes linking the accretion disk and the crown may have changed over the last 6.5 billion years. This implies a transformation in light emission and the way black holes grow and evolve. The research team expects to use the complete data of the scanning performed by Rosetta to detect even more distant quasars. This will confirm whether the observed evolution is a real trend or influenced by biases in data selection.